Welcome to Pre-Calculus video for skill number 37. I can generate a quadratic equation when provided a graph, and graph quadratic equations when provided the equation. So the trivia question, here we've got our backpack, and along the side we have these little straps here. They also exist on the bottom of the pack. And the trivia question is, what are those straps called? Alright, so for this video, there's two forms that we should know for quadratics. There is the vertex form of a quadratic, which is a times x minus h squared plus k. And then there is the standard form, which is ax squared plus bx plus c. Now, the greatness of the vertex form is it's pretty easy to see that this is a transformation. We're going to go right h units and up k units, and then we're going to vertically stretch it by a factor of a. The standard form is more typically the way that we'll see an equation, but when we're going from a graph to an equation, we usually start here and then go in this direction. So let's take a look at some examples. Alright, so we're kind of comfortable with our transformations, and we can see what we have here is a quadratic, and the quadratic has shifted to the left 1 and up 2. So if we wanted to write this in vertex form, we're going to have, so our parabola is x squared, but because we're going left 1, we want to say plus 1. That tells us left 1. And then we're going to go up 2 units. And we would stop here, but we want to make sure that there's no vertical stretch. And the easiest way to do that is we check where our next crossing point is. And in this case, it looks like we've gone out 1, up 1. So our vertical stretch is actually only 1. So our function in vertex form is x plus 1 squared plus 2. So we have written the equation in vertex form. Now what we need to do is convert it to standard form. And so what that means is expand it out. So if we expand our x plus 1, we're going to get x squared plus 2x plus 1, and then there's the plus 2 at the end. So our expanded form, or the standard form, is going to be y equals x squared plus 2x plus 3. I generally think the vertex form is better when you're thinking about it graphically. The standard form does have its benefits, but if we're going straight from a graph to an equation, the vertex form is best. Let's take a look at problem number 4. We're doing the same thing, and in this case we have shifted left 1 and up 2 also. So our x squared becomes left 1, so x plus 1 squared, and then up 2. And then our vertical stretch, we actually see it opens downward. So that's going to put a negative in the front, and then we're going to check where our next crossing point is, and we see that it crosses right there. So that is out 1, down 3. So usually a quadratic has out 1, down 1, out 1, down 3. Well, because on our first time we went 3 times as far, we have a vertical stretch by 3. So this is our equation in vertex form. Y equals negative 3 times quantity x plus 1 squared plus 2. If we want to convert that to standard form, what we're going to do is first we will distribute the exponent in, and then we want to distribute the negative 3 in, so negative 3x squared minus 6x minus 3 and then there's still the plus 2, and then we get our final answer as y is equal to negative 3x squared minus 6x, and then negative 3 plus 2 is negative 1. So there's our standard form. So, quick review, you find that it's shifted left 1 up 2, that it's reflected upside down, and then that it's been vertically stretched by 3. Alright, let's take a look at one more like this. So in this case, we find where our vertex is. So the vertex of our parabola is located 2 to the left and 3 up. So here's our 2 to the left, and then 3 up. We notice that it's opening downward, so it's been reflected over the x-axis. And then we want to talk about the stretch, and this is where it can get a little bit tricky. We see that the next crossing point is right there. Oh wait, nope, here's one. This is the best one. So with that crossing point, instead of going out 1, down 1, what we get is out 2, down 1. So it's been horizontally stretched by a factor of 2. What this means is the quantity that is getting squared needs to be multiplied by the reciprocal of 2, since we have a squaring function. So the quantity getting squared needs to be multiplied by the reciprocal of 2. And that makes it y is equal to negative quantity 1/2 quantity x plus 2 all squared plus 3. And that's kind of a high level problem where you've got a horizontal shift and a horizontal stretch. I don't think I would combine those two on the test just because they can get complicated. Or if I did, it would be kind of an advanced level question. So be careful when you've combined a horizontal stretch with a horizontal shift. Now if we wanted to factor this or distribute this all out to put it into standard form, we could go ahead and do that. I'm going to do it off camera just to conserve time. Alright, there we have it in standard form. First I squared the 1/2 and squared the x plus 2, and I brought the negative in. Then I distributed the 1/4 into this, and then I added 3 at the end. Let's take a look at the second page. Alright, this says for each of the following quadratic functions, find the vertex, the vertical intercept, and the horizontal intercepts. So one thing you may not be aware of, a vertex occurs at x equals negative b over 2a. So if we're going to do that for this function, our negative b over 2a is going to be negative 6 over 2 times 3, which is equal to negative 1. So our vertex occurs at negative 1 comma, and then we find out what is f of 1, so f of negative 1. So we stick negative 1 into the function, and we're going to get 3 minus 6 minus 9. So 3 minus 6 is negative 3, minus 9 is negative 12. So our vertex occurs at negative 1, negative 12. The vertical intercept, or if you want to call it the y-intercept, that's going to occur where x is 0. So we evaluate for 0, and we get z of 0 is equal to 3 times 0 plus 6 times 0 minus 9. So our vertical intercept is going to occur at 0, -9. And then finally we need to find the horizontal intercepts. And horizontal intercepts are found by factoring our quadratic and applying the zero product property. So if I factor the quadratic, I notice that I can pull a 3 out. I'll get x squared plus 2x minus 3. And then if I factor that even further, I'm going to get 3 times x plus 3 times x minus 1. And to find the horizontal intercept, we set that equal to 0, and we apply the zero product property, and we get horizontal intercepts at -3, 0, and 1, 0. So those are the values that would make this whole thing 0. If we put a -3 in here, the whole thing is 0. If we put a 1 in there, the whole thing would be 0. From there, we can actually draw a rough graph with those 4 points. So first we plot the vertex is at -1, 12, -12, so somewhere right around down there. That would be the vertical, or the vertex. Then we have a vertical intercept at 0, -9. So 0, -9 is right there. And then we have horizontal intercepts at -3, 0, and 1, 0. So there is the 4 points that will help us create a drawing. We should know that this blue dot was our vertex, so that's going to be the bottom of our parabola. So our parabola is going to pass through these 4 points. So something approximately like that. We can get more specific than that, but if we plot those 4 points and draw the curve through it, that's sufficient. Let's try it out on number 10. So our vertex again occurs at a point that would be -b over 2a. So -b over 2a is 14 over 2 times -2, -4. So that's reduced -7/2. And then if we want to figure out the y-coordinate, we need to plug in -7/2 into the function. So -2 times -7/2 squared minus 14 times -7/2 plus 12. And plugging it into a calculator, I got 36.5, which is clearly off the graphic provided. But let's move forward. The vertical intercept, again, that's going to occur where x is 0. So if we plug 0 into this function, we get 0 minus 0 plus 12. So we have a vertical intercept of 0, 12. To get our horizontal intercepts, we could try factoring, and if we went down that path, we would see that there is no possible way to factor it, at least not with rational numbers. So the next approach would be to use the quadratic formula to identify the roots. So a little refresher, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And if we start plugging in those values, we're going to get 14 plus or minus the square root of -14 squared minus 4 times -2 times 12 all over 2 times -2. And I'm going to do this in a calculator and get 2 different x values. Alright, did the calculator work and got, in blue, this is the exact value. In red, I've given the approximate values. So those approximate values are what's going to be useful for graphing the equation. So we get negative 7.7-ish, that's somewhere over here, and then 0.7-ish, somewhere over there. Our vertical intercept occurs somewhere up around 12, and then our vertex is actually way off the graph, but it's, I don't know, somewhere up there. So our graph, if we were to graph it all, would look roughly like that. I'm going to, on the skill test, make sure that the equations I give you fit on the graph, so you don't have to worry about that. Okay, let's take a look at the next problem.
All right, that's far enough, buddy. Come on, get out of here. Go on, get out. Come on, get out of here.
Okay, this says rewrite the quadratic function into vertex form and then graph the function. So if I want to write it into vertex form, it would be good if I knew what the vertex was. So let's find the vertex of this equation. Negative b over 2a is negative 2 over 2 times 1, which is equal to negative 1. So our vertex is going to occur at negative 1, and g of negative 1 is equal to 1 minus 2 minus 3 is negative 4. So our vertex is at negative 1, negative 4. Which basically means we've gone to the left 1 and down 4. So we could say to the left 1 and down 4. And then the last piece is we notice there is no stretch on our x squared factor, so that number would be a 1. So here we have written the equation into vertex form. With no stretch, we follow our typical pattern for a parabola of out 1, up 1, out 1, up 3, out 1, up 5, out 1, up 7, etc. So out 1, up 1, out 1, up 3, and then out 1, up 5. And we have what it takes to draw a parabola. Pretty straightforward. What you need to do is first find the vertex and then think of that vertex as a shift from the origin, so left 1 down 4 in this case. And then you're going to look at your leading coefficient, and that will tell you what sort of stretch you have going on. So let's take a look at the second problem, number 16. If we find our vertex, this will occur at negative b over 2a. So that's 6 over 6, or 1. So our vertex occurs at a x value of 1. And if we stick 1 into the equation, we're going to get k of 1 is equal to 3 minus 6 minus 9. So negative 12. So what we have here is a shift to the left 1, sorry, to the right 1 and down 12. So you can say x plus 1 squared and then down 12. Finally, we should look to the number in front to determine the stretch. So the stretch is a vertical stretch by a factor of 3. So let's go ahead and plot that. Vertex to the right 1, down 12. So right about there. And then the vertical stretch is by a factor of 3, which means out 1, up 3 times 1, out 1 up 3 times 3, out 1 up 3 times 5, etc. So what we have is a parabola which goes like that. Y equals. There's our vertex form. And again, we'll get opportunity to practice these in class, but if you want to take a shot at doing the odd numbers, that would be wonderful. Alright, hopefully after this video you're more comfortable graphing quadratics and generating equations from graphs. The answer to the trivia question, albeit a rather mundane question, is what are these straps called? They are compression straps, and the intention is so that you can secure your load tight into a single package, which makes it easier for backpacking without all loose dangling bits on your backpack.